This is the Math 2 Honors Unit 8 review, and we are looking at number 1. Number 1, we have this right triangle drawn, and we're looking for the value of x. We can use Pythagorean theorem, which says x squared plus 16 squared is equal to the hypotenuse squared, and the hypotenuse squared is x plus 9. So x plus 9 is my hypotenuse, and then quantity that squared. So we're going to rewrite this. X squared plus 256 is x plus 9 times x plus 9. Multiply that out. X squared plus 256 is x squared plus 9x plus 9x plus 81. Add your 9's together. X squared plus 256 is x squared plus 18x plus 81. At this point, we can subtract x squared from both sides, and we could subtract 81 from both sides. 256 minus 81 is 175. And then divide by 18. So you get 175 over 18 is our value of x. Check to see if you could reduce that. And I don't see a way, so that's just our answer. Okay, number 2. We're looking for the value of x again here. Look, our radius here is intersecting a secant segment, a secant of the circle, which is length 20. It's hitting that at a 90-degree angle, and when that happens, you can see that it actually bisects that segment. You can use triangle congruence to prove that. So anyhow, we have a length of 10 for the segment I'm tracing. Also, the segment here is 4, and the length from the center of the circle to the circle, that's your radius, is also x here. And so we can use Pythagorean theorem again. 4 squared plus 10 squared is our hypotenuse, which is x squared. So 16 plus 100 is x squared, or x squared is 116. Take the square root, it's going to be positive. 116 is 2 times 2 times 29. And so we can simplify this to 2 square root 29. Number 3, we're looking for the measure of angle ABC. Just this angle right in here, and we're given some clues. First of all, we have an inscribed angle at 51 degrees, which is half the measure of the arc BC. So the measure of arc BC is 51 times 2, which is 102 degrees. AB we see is 86, and so the measure of arc AC is going to be 360 degrees minus the 86 and the 102, because all three arcs, the measure of all three arcs make a full circle, which is a full 360 degrees, and so this measure here of arc AC is going to be what's left over when you subtract 86 and 102 from 360. When we do that, we end up getting 172 degrees. Then the angle we're looking for is the measure of angle ABC, which is the inscribed angle in the circle that corresponds with that arc length that we found. And so we know that that's half the measure of 172. So the measure of angle ABC is a half of 172. Which is 86 degrees. Number 4, we're looking for the value of x, which is the angle here. We have two chords here in the circle, and they're not necessarily intersecting at the center of the circle. So be careful here. There's nothing here that indicates that we're looking at a radius or anything of the sort. The center may be somewhere else. But what we do know is that angle x is equal to 1/2 the measure of 88 degrees plus 86 degrees. So 88 plus 86 is 174, and half of that is 87. Number 5, we're looking for the measure of the arc IFG. I'm going to highlight it. IFG, so going this direction. Notice we have half a circle plus a bit more. So that's going to be 180 degrees plus 70. Which is 250 degrees. Number 6, we're looking for the value of y. And in this case, y squared is equal to 2 times 2 plus 9, which is 2 times 11, or 22. So y is the square root of 22. Seven, we're finding the measure of angle G. And I'm not seeing an angle G on this, so what we're going to do is we're going to find we'll find A, B, C, and D. Okay, so first of all, angle A and 108 are supplementary, so we know that A plus 108 is 180. Subtract 108 and you get A is 72 degrees. Let's see here, same idea for B. B plus 92 is 180 degrees. Subtract 92, we get 88. And let's see, now for C, We can view B as an inscribed angle corresponding to the measure of arc C and D. So what we have here is we know B, which is 88. I'll write that in here. We also know A is 72. I'll write that in there. And so we know that C plus D is equal to 2 times 88, which is 176. We can also look at C and 114 with the angle 108. And I could write C plus 114 is 2 times 108. And here we can solve for C. 2 times 108 is 216. Subtract 114. You end up with 102 for C. Plug that into the next equation. 102 it should be, plus D is equal to 176. Subtract 102 and you get 74. And now we found A, B, C, and D on F. On number 7. So here we see that the diameter is crossing a chord in the circle at a 90-degree angle. And so we can easily show that it's bisecting it. And so we know the lengths 4 and 4. Let's call this full length here that we don't know x. And so we know that 3 times x is equal to 4 times 4. And so solve for x, you end up getting 3x is 16. So x is 16 over 3. So our diameter, which is the full length through our center of the circle, is going to be 3 plus 16 over 3. I'm going to get a common denominator, so that's 9 over, multiplied by 3 over 3. So you get 9 plus 16, which is 25 over 3. So our radius is half that. 25 over 3 times a half is 25 over 6. Number 9, we're looking for the measure of angle x and the measure of angle y. Notice here we have 48 degrees is equal to 1/2 140 degrees minus x degrees. And so that relation right there will help us solve for x. I can multiply everything by 2. I get 96 is equal to 140 minus x. Subtract 140. I get 64. Negative 64 is equal to negative x. No, that's wrong. Not 64. That should be 44. And so x has got to be positive 44. Or we could say x degrees is positive 44 degrees. And then for y, notice y is tangent to the circle, but that angle's not going to be 90 degrees because it's only perpendicular to the radius. But what we do know, we just found out that x is 44. So we got 140, we got 44, and so we can find the missing arc measure here. I'll call it z, because we have z plus 44 plus 140 is 360 degrees. So that's z plus 184 is 360. So z is 360 minus 184. Which is 176. And the measure of angle y is going to be 1/2 the measure of angle z, which is 88 degrees. Number 10. So 10, we have this diagram, and we're going to find quite a few pieces. So starting with part A, we're looking for the measure of angle SUR. Okay, the measure of angle SUR, it's a inscribed angle, and it's corresponding to the 102, and so it's equal to 1/2 of 102, which is 51 degrees. Then we want the measure of arc QR. We'll notice that QS is a diameter, and so we get half a circle from QRS. We know part of it's 102, and so this is going to be 180, which is half the circle minus the 102. And we get 78 degrees. Next we have the measure, so arc RST. So we found that this is 78. We got that this is 51. I'm just going to write those in so far. So RST. Again, RT is the diameter, and so we can say that we can do this the same way we did part B. So it's 180 minus 102, and we get 78 degrees again. Next, the measure of angle TOU. So that is the average of 36 and 102, which is half of 138, which is 69 degrees. And lastly, we want the measure of UQ. Well, we know that TQ is going to be the same as RS because RT and QS are both diameters, and they're going through the center of the circle. Vertical angles are congruent, therefore, and they both correspond to those intercepted arcs. So QT is 102, and then we subtract out 36. And we're left with 66 degrees. Number 11, we're looking for angle X and measure of angles Y. So X is going to be 1/2 182. Which is 91 degrees. Write that in. Here's 91. This angle over here is supplementary, so 180 minus 91 gives us 89. And so Y is going to be double the 89. Which is 178. You can also check 182 plus 178 should add up to 360, and it does. Number 12, we're looking for the measure of angle Y, and if the measure of angle Z is 94. So this is 94 degrees. Well, if Z is 94, then X is going to be 360 minus 94. Which is 266 degrees. And then Y is going to be 1/2 266 minus 94. Which is 1/2 of 172. Which is 86 degrees. We're looking for angle X. Angle X is the measure of this arc right here. They give us 17 degrees in this intercepted arc here, or sorry, this inscribed angle. So A is double 17, so 2 times 17, or 34. Also, we have a diameter, so this is 180 degrees here. So X is 180 minus 34. Which is 146. Number 14, we're looking for X. If GE is X minus 3, DE is 8, EF is 4, and EH is 2. So we know that 2 times X minus 3 is equal to 8 times 4, or 2x minus 6 is 32. Add 6, you get 2x is 38, divide by 2, x is 38 divided by 2, which is 19. For 15, we're looking for angles A, B, and C. So A is going to be 2 times 39, which is 78 degrees. B is going to be 90 degrees, assuming B is right here. This is 90 degrees because it's a semicircle. It is the inscribed, or so this is the intercepted arc. That's 180 degrees, so B is half 180. And for C, well, we have 50 degrees, so this arc right here is 180 minus 50, which is 130. And so C is half of that. Which is 65 degrees. We're looking for angle X, and we're told that B is 40. So B is 40, A is going to be 80. And then notice we have congruent chords here, so both these are X. And so we know X plus 80 is 360. Or 2x plus 80 is 360. Subtract 80. We get 280. Divide by 2, you get 140. Number 17. So in 17 there are no clear instructions, but let's see what we can figure out. So first of all, we see that RS is tangent to the circle, and that meets at a 90-degree angle. Also ST is tangent to the circle. PT is a radius, so is PR, so is PQ, so is PU. And if you look at these two triangles, I'll highlight them. So we got this triangle here. That's congruent to the triangle below it. They share a hypotenuse. They're both right triangles, and so they're congruent by hypotenuse leg. So this is also 16. And then all three angles inside a triangle add up to 180. We already have a 90, so looking for the essential angles, we have 90 minus 16 is 74 degrees. And again, they're congruent. This is 74 degrees. We have vertical angles. This is 74 degrees. We have an isosceles triangle in the mix here, and so we know that these two are the same. So we have, let's call them angle X, so 2 times X plus 74 adds up to 180. So subtract 74 from 180, you get 106 Divide that by 2, you get 53. So both those angles are 53 degrees. We can also find this missing angle in here because QO is a diameter, and so 74 plus 74 plus something equals 180. They're supplementary. So 2 times 74 plus that missing angle, I'll call it Y, is 180. 2 times 74 is 148. Subtract 148 from 180, and you get 32. And one more angle. Again, QO is a diameter, so 74 is supplementary with this angle. So 180 minus 74 is 106. So we found all those angles in the center. We found all the angles in the triangle. Is there anything else that we can look for here? I don't think so. We have the, if we look at the angles of the arc measurements, they just match the central angles. So 74, 74, 32, 74, and 106. There's nothing in terms of length that we know here, and so that's as good as it gets. Number 18. Find the measure of angle MNL. Okay, so this angle here, if the measure of MJ is 100 degrees and the measure of LK is 40 degrees. So MJ got 40 degrees out here. Sorry, that's 100 degrees. I read it wrong. And LK is 40. So we can find, first of all, the measure of angle N. So N, or measure of angle N, in that case, is going to be 1/2 of 100 plus 40, which is 1/2 of 140, which is 70. Okay, so we got 70 degrees here, and the angle we're after is supplementary to 70, and so this is definitely not drawn to scale, but that's okay. So we're going to have 110 degrees. That's what we're after. So that's our answer, 110 degrees. Number 19, we're to find the measure of angle GIJ. So GIJ, that's this angle right in here. I'll call it angle X. So we are given some measures of arcs, and we know all 4 of them. We're missing one. I'll call this Y. So 68 plus 31 plus 115 plus Y makes the full circle, makes 360 degrees. So those are all degrees. And so then we can solve for Y here. 68 plus 31 plus 115 is 214. Subtract 214 from 360, and we get 146. So that's 146 degrees there. That arc is intercepted by angle X, which is an inscribed angle. So angle X is 1/2 of the 146, which is 73 degrees. And that's what we were after here. Number 20, the last one I think, yeah. We're to find the measure of the arc PTR. And we know that the measure of angle PQR is 35. Okay, so that whole angle there is 35 degrees. So in this picture, there's a couple things. I'm going to highlight the major arc PTR, and we're going to label that X degrees, and I'm going to highlight the remaining part, arc PSR, and we're going to label that Y degrees. And so we know that 35 is 1/2 x minus y. But we also know that x plus y is full 360, and so y is 360 minus x. And so I'm going to substitute that piece in for y here. And so I get 35 is 1/2 x minus, careful, we got a couple parentheses here, 360 minus x. Distribute the negative, we get 35 equals 1/2 x minus 360 plus x. Keep going, 35 is 1/2 of 2x minus 360. To multiply by the 1/2, distribute it, and we get x minus 180. So now 180 plus 35 is 215. And if we're looking at angles, that's what x is. And x, we're looking for PTR. PTR is x, and so that's what we're after.